Alright, today's problem. A ball is dropped from rest from the top of the building, right here, and the ball passes a 1.2 meter tall window in 0.09 seconds. Find the height h shown in the diagram below. Okay, so this is a kinematics question where we have known variables and we have unknown variables. So in any kinematics question like this, we have to identify what we know and what we don't know. So in any kinematics problem, we have to identify the following. S, the displacement, U, the initial velocity, V, the final velocity, A, the acceleration, and T, the time. So this is what we call a suvat table. So let's identify variables that we know. Well, we know at this point the ball is in rest, so U equals 0. And we know for this entire time when it's falling, not just at point H and not just at point 1.2 at this window, this entire acceleration is 9.8 meters per second squared because it's downwards. So in kinematic questions, we have to know at least 3 variables to solve for the other 2 variables. To get the other variable for point H here, we can look at the final velocity here, because the final velocity here equals the initial velocity here. Because if you see, this ball falling to this interval, that's the final velocity. But this ball falling to this interval, that's the initial velocity, and that will be the final velocity there of this 1.2 meter interval right here. So what variables do we know about this 1.2 meter interval here? Well, we know the distance is, of course, 1.2 meters. We don't know the initial velocity. We don't know the final velocity either, but we do know that the acceleration is, of course, 9.8 meters per second squared, and we know the time it takes to fall through this entire window is 0.09 seconds. We have to choose the suvat equation that uses S, A, T, and also U as our variables to find. So it's going to be this equation, which states that S equals UT plus 1/2 AT squared. So what values do we have? We're given that S is 1.2. Well, we don't know U, so we can just write that as 0.09 U plus 1/2 9.8 times 0.09 squared. We're going to get 1.16 equals 0.09 U. All we have to do now is just divide 0.09 on both sides to isolate U. It's going to give us U equals 12.89 meters per second. Now we can label this final velocity at point H as 12.89 meters per second, considering it's the initial velocity at the interval 1.2 meters. Now that we know the final velocity at the interval H is 12.89, we can set up a new SUVAT table where S equals H, we're trying to find, U equals 0, as we labeled before because it's resting. Our final velocity equals 12.89 meters per second. Sorry, that should be meters per second. And our acceleration is still 9.8 meters per second squared. So based on the variables we have, we're going to use the equation V squared equals U squared plus 2AS. V is 12.89, and then V squared would be 12.89 squared, equals U is 0, so I'm just put that as 0, plus 2 times our acceleration, which is 9.8, and the distance H that we don't know. So this is going to be 166.152, 18.6 H, and then you're just going to divide 19.6 on both sides. You're going to get your final answer as 8.48 meters equals our height that we were trying to find. And yeah, that's the answer. Let's test this out. Here we have our setup before, where there is a 1.2 meter window and there is a ball at the top of the building, which means that when the ball is 8.48 meters displaced, then that means our velocity has to also be 12.89 meters per second. So let's just play this and test to see what happens. And let's just go forward a little bit here. And yes, as you can see, at 8.48 meters fallen, our velocity is exactly 12.90 meters per second, just like we predicted. And yeah, that means our prediction is correct here. And yes, that confirms that our answer of 8.48 meters is correct. And yeah, thank you for watching and have a great summer.